Question 8. A more complicated question on this test, probably the longest solution, so get working on that. We've got cos 2x here, and we've got a cosec cubed here, and we need to get everything in terms of sin x. We know that, okay, so we're looking at part A. We know that, cosine of 2x is one of our trig identities. There's of course 3 for double angle cos formula. 1 minus 2 sine squared x, and we know that cosec cubed of x is 1 over sine cubed of x. And we're going to use those substitutions in the equation now. Instead of writing sine x, we're going to use s for sine x. So here we've got 1 minus 2 s squared, and for this one we've got 1 over s cubed. You can find us with those substitutions you're going to do an awful lot less writing than you would do if you had to write all the trig functions down. So our equation that we started off with, 4 cos squared, becomes 4 brackets 1 minus 2s squared minus 3 s for the sine x and 1 over s cubed for the cosec cubed plus 6 is equal to 0. Multiplying through by s. Well, let's simplify it first. Let's get rid of the bracket. 4 minus 8 s squared minus 3 over s squared plus 6 is equal to 0, and we'll multiply up by s squared and get 4. Okay, I can actually, let's go ahead and do this. 4s squared minus 8s to the power of 4 minus 3 plus 6x squared is equal to 0. Of course I could have combined the 4 and the 6 at an earlier stage. Moving it all over to the right hand side of the equal sign gives me 8 s to the power of 4 minus 10 s squared plus 3 equals to 0. And so that is what we were looking for in the question. For part B, we need to solve the equation for x in the interval that we've got from 0 to pi. It's power of 4, but it's actually a quadratic in s squared. So let's just make a note so you can have a little think about the fact that this is a quadratic in s squared, because this term is s squared squared, this is s squared, and there's our constant. And we're going to factorise that, and let's see what happens. I think we'll have a go at starting it like that. That will give me a term in 8, that will give me my 8x s to the power of 4. If I put a 3 here and a 1 there, I can make that negative and this positive, and excuse me, let's undo that, I made a mistake. This needs to be a negative sign because both values, and that's absolutely not right, so we'll undo it again. It doesn't always work first time, Patrick. And we'll put the 3 there, and we'll put the 1 there, and we'll make them both negative, and that looks about right. Giving us a little bit more space here. So for the two solutions, I've got 4s squared minus is equal to 3, or 2s squared is equal to 1. I think we can do that step in our heads. This is giving me s squared is 3 over 4, so s is plus or minus root 3 over 2. Rather nice. Look, there it is. That's we should recognise plus or minus root 3 over 2. And this one will give me s squared is a half, and s is therefore plus or minus, don't forget the plus or minus, 1 over root 2. Again, nice value, remembering that s is of course the sine of x, and suggesting that we've got the angles from our special triangles here. Going back to the question, we're talking about we're in the interval from 0 to pi. So it's very important that we know that the sign of x, which of course is our value for x, is going to be greater than or equal to 0. So we're not interested in the negative values for this particular interval. So our solutions are, and we know by heart, that the inverse sine of root 3 over 2 will be pi over 3 solutions, pi over 3, or in the second quadrant 2 pi over 3, and the inverse sine of 1 over root 2 in the first quadrant is pi over 4, and in the second quadrant is 3 pi over 4.